Welcome back, everyone. I am really happy today to show you another lesson in my pre-calculus Math 12 in the unit 1 of the lesson 3 and 4, which is transformation of the coordinates of the function and how to sketch them. Now there are a lot of transformation, and I have present the transformation of the coordinates and show you how to find the coordinates undergone the transformation in my MS PowerPoint presentation. However, I would like to show you one more video on how to sketch the transformation of the function. Now, I'm not be able to show you on sketching as I have shown you in my PowerPoint presentation, but I would like to show you at least how to calculate the coordinates, how to sketch the transformation by 2 or 3 examples. So I hope you will enjoy my video today, and this video will be incorporated into my PowerPoint presentation as well. So let's take a look at what we're going to do today. Now on my board, I have the original function icon y equal x. So this is the original function. It already sketched and given it to you. Now our task is going to transform this original sketching to a new sketch, to a new function. Undergone this transformation, y equal f bracket 1/2 of x plus 1. Let me recall a little bit the previous lesson to you. If we have a letter A, so the form of transformation look like, so this is f of x. When it transform, it could become a of f, and then we have a letter B inside, and x, and might be plus or minus C, and plus or minus D. So the A here, letter represent for the vertical stretch, and the B here represent for the horizontal stretch, and this letter C here represent for horizontal shift, and letter D represented for vertical shifted. It could be up or down, and the C here could be shifted to the left or to the right. And the A here, one more information I haven't included in here, which is could have a reflection over the x-axis with the negative in front, as well as reflection over the y-axis. So you can see that if we combine all this transformation, it looks very complicated, isn't it? So now let me show you to sketch a simple one first, and then I will show you to sketch the next more complex one. So now let's sketch this transformation here. Now, first of all, to sketch this, I should factor out the numerical in front of the letter x here. So let me factor it out. Actually, in this case, I don't have to factor it out, right? Because we don't have any negative or we don't have anything, so it might be interfere and make us make an error. So in this here, we don't have to. But let me tell you how we're going to sketch this function. Now, if you just look at this and guessing how the x coordinate compress and y compress is very hard. But make sure that we do the good job, and we do the accurate. We do it in accuracy. So how do we do that in accuracy? The only way to do it in accuracy is make sure that we have a coordinates, right? And we calculate the coordinates appropriately. So let's pick up a base point from the coordinate here. So this is the original. So I'm going to mark this base point, right? So the x here is 1 and the y here is 1. Now this base points symmetry, so it will be -1 and 1. And this is 0 and 0. This is important point as well. These base points produce the shape of the image, right? And the x-intercept here is important, so I'm going to mark this as -2 and 0. So we base on these base point 1, 2, 3, 4, and we sketch them for the new image. So now let's first identify what type of transformation. This transformation here is horizontal expand, right? Because we have actually sometimes I a little bit confused in terms of we use the word expand or compression. But let's see the image and then we will decide it our okay. So let's say this is horizontal, right? So we're going to multiply any coordinate x by the, so let me just say expand first, okay? By, and if the image doesn't look like that, we can change it later. So let's just here just say horizontal expand by 1 over b, and 1 over b, our b is 1/2. So 1 over 1/2 is become 2. So now we know that our x coordinate will expand, instead of 1 will become 2, and instead of 2 will become 4, instead of 4 will become 8, something like that, right? So now let's mark a few coordinate points and we will sketch this graph. So our base image is, let's start from here, -2 and 0. The next one will be 1 and 1, -1 and 1. And the next one will be 1 and 1. And actually, I forget the 0 and 0, which is important. And the next one will be 1 and 1. So these are the base point. And we're going to calculate our coordinate based on this transformation. So I'm going to say this will transform to horizontal expand by a factor of 2, because instead 1/2, remember we have reverse, do 1 over b, so that is 2. So -2, and we don't have a negative in front, so we're not worried about reflection or anything. We also don't have an a here in front, so we're not worrying about the vertical expand. It's just horizontal expand in here. So here will be -2 times with 2 will be -4. And the side will be the same because we're not reflected, right? So we're not going to switch in the side. Whatever the side is supposed to be the same. We just expand it by a factor of 2, 1 over b, which is 1 over 1/2, which is equal to. So we multiply this with 2. -2 times 2 is -4. Now, the 0 is, we're talking about, this is x and 0 for y. So here in this transformation, we have a letter D, which is +1, which will shift up the graph by 1 unit. So any y coordinate will move up by 1 unit. So our y0, when it move up, you add into 1, so it become 1. Now this form will be minus 1 times 2. So again, it will be minus 2. And 1 here is y. We add into the letter D, which is here 1 unit. So 1 add 1 is 2. The next coordinate, 0. If 0, we multiply with 2, stay as 0. Now for y, 0, we move up to 1, so it become 1. This last coordinate, if it is a 1 for x, we multiply with factor of 2, so it becomes 2. And our y is 1, adding with 1 here, so it becomes 2. So now let's put in the point, plot the points, and we shape the graph. So we remember this is our new graph, right? So this is new y, our new y in this column. So we follow this, minus 4 and 1, 2, 3, 4, minus 4 and 1 right here. Minus 2 and 2, minus 2 is here, and 2, so 1 and 2, so it's right here. 0 and 1, 0 and 1, so it's right here. And 2 and 2, so 2 and 2 is here. So let's see how I'm going to shape this one. So obviously, we know that this shape will be connecting like this. And this is the circle, look like an arc, right? An arc circle, like a circle. So it go like this, and it go like this. Now, this is the last one. Now I should mark one point here more. So this base point, let's say this is 3 and 1. So let's do one more. 3 and 1. And how do we change 3, 1? 3 times with 2 will become 6. 1 add to 1 will become 2. So this is 1, 2, 3, 4, 5, 6. So our 6 about here. And our 1 is, our 2 is the same level. This is 2. So it's like this. So that is the shape we're expecting to have it. And undergone this transformation, you can see obviously I use the word expand. I don't want to use the word compress because this factor, even though small, but because we reverse. So we expand, actually the image become horizontal expansion. It large in a horizontal way. So I use the word expand is accurate. Now sometimes because the language in English and my language is reverse, right? If we say expand, they say compress. If we say compress, they say expand. Usually sometimes it reverse like that. Not on the words, but my language is very like opposite, like in the reverse with the English words. So sometimes I have to be careful in terms of translating. So anyway, so now I read in the textbook. I saw some of the textbooks stated like horizontal compression of a factor 1/2 or something like that. And for some teachers, right, I can see that they translate it in the way that, and that's why sometimes myself is a confusion for me. So I just want to make sure that I use the correct word. Now, to my opinion, this is the expansion of the horizontal. It's not compressed. Even though the factor is compressed, right, it 1/2. but because we reverse it. And the image, final image show us is the expansion of the x coordinates, so I use the word expand. That's my decision. Okay, so this is horizontal expand of a factor of 2. Now maybe it's awkward a little bit because this is 2, so actually it's true, but because we have the fraction which is small and we say expand, so it contradicts, right? But anyway, because we reverse, so I don't know. It's up to your choice. So if you hear any other teacher call this compressed by a factor of 1/2 or whatever, you know what I mean. Okay, so sometimes the English language is a little bit confusing. Like, I don't know, to my language perspective of my language is reversed with whatever my language say. Okay, so now I have shown you how we sketch the graph easily based on the transformation. Now let's do this one. This one is very complicated, right? So let's first identify the transformation first. So how do we identify? Now instead of say vertical, now I'm going to just say A, right? And based on this formula, we know this A we're talking about, right? So this is vertical, and we have a reflection as well. So minus A equal minus 2. So keep in mind, we have a negative in front, which is including the reflection. And our B, hold on, I'm sorry. Before we do this, let me factor out this, because this is the complex expression. So I'm going to factor it out first before I'm going to do anything. So now I'm going to factor out y equal minus 2 f. I'm going to factor out big square bracket, and I put minus 1/2 outside. Inside I have an x. And because I factor out this minus 1/2, so this minus 1 affected by this factor. So instead of minus 1, I should put plus 2. And you see that it changed the transformation, right? Because 2 divided by 2 give you back to 1. So when I factor, I make sure that I change it in the way that it's the same like the original, right? So minus 1, but I change into 2. 2 divided by 2 will become 1. Now, the sign original is negative, right? This is the original form written, minus 1. And you want this sign to be plus, because when you tie this minus with plus, it will become minus like that. So be careful in terms of the sign and notation, something like that, right? Okay. Now, so this is minus 2 in front of this expression. But let me see, let me check the bracket here to see if we cover the whole thing or it's just this one. So give me 1 second. Sometimes we got to be careful about the way they write, right? Okay, so that's correct. They just put the bracket in front of this group. So if they put the bracket like that, then we have to tie minus 2 to here, right? That's what I mean. But when we don't have the bracket cover like this, it means the letter D doesn't change. So we just shift up by 1 unit, okay? So now let's calculate the coordinate. So again, I'm going to mark these base point coordinate again, right? So I'm going to follow this exactly the same. So the first point will be minus 2 and 0. And the second point will be minus 1 and 1. So these are the base points. And the third one will be, I'm going to put here, okay, 0, I put here, 0 and 0. So that's third one, just point here. The next one will be 1 and 1. And the next one will be 3 and 1. Okay, so let's check. So from this point, we're going to identify. So let me show you the transformation first, right? So we have a reflection on the axis, followed by the expansion of the factor 2 for the y-coordinate. We have a reflection on the y-axis because this negative sign, followed by the expansion of the x-coordinate by a factor 2. Then the x-coordinate will be shifted to the left by 2 units, and the whole function will be shifted up by the y-coordinate will be shifted up by 1. So that's how we identify the transformation. So now we're going to change this, right? Follow the transformation. And because this is a complex expression as well as a transformation, so the best way to do it accurately and correctly means we got to follow the order of operation. The same like in elementary, you learn the order of operation. Here we follow the order rules of transformation. So the order rules say we should do expand of vertical and reflect it, right? Now, the reflection and the expansion can go the same with the order. And you can do the vertical first and then horizontal, or you can do the horizontal first and vertical. But the shifted left or right and up or down have to be the last transformation. So we follow the order like that. So it sounds like complicated, right? So a lot of memorization, like any subject we have to memorize at some point. We have to know the rules, we have to follow the order. And practice keep perfect. Okay, so here, let me explain it to you. We have x-coordinate. Now, do you remember x first and then y, right? So minus 2. So now let's talk about vertical, which is the y. So we're going to multiply the y with 2. So the y here is 0. When you multiply with 2, it doesn't change. Now, the x-coordinate, we haven't talked about it, so still stay the same. Now, the 0 times with minus 2 doesn't matter, still a 0. However, you got to add it to 1 for the y-coordinate, right? Because we shift it up like this. So that is the first transformation. So let's talk about the first one. Now, it undergone another transformation, which is reflection over the y-axis. So the negative, because reflect will be reversed, and also expand by a factor 2. So we multiply minus 2 with 2, which is 4, but we have to do the reflection. So instead of minus 4, we just twist the side, become 4. Now we're going to subtract this by 2 units. So 4 minus 2, and that for x. And for y is 0. And we shift up 1 unit. Yeah, because the 0 here, when you multiply with minus 2, it's just the same, right? And then you shift up 1 unit. So that's the answer. And the final answer calculate is 2 and 1. Okay, now let's do this one. So the first transformation, we're talking about Now we can do the x first and then do the y, it doesn't matter, right? So minus 1 will time with 2 will become 2. However, because reflection, so instead of negative will become a positive. So 2, then you have to subtract the 2, right? And the 1 you time with minus 2, so it becomes minus 2. So the y coordinate here times with minus 2 here because the factor of the expansion. So 1 times minus 2 follow the reflection as well. So it will become minus 2. So the final transformation point will become 2 minus 2 is 0 and minus 2. Minus 2 should be adding with the 1 here, so it becomes add 1 as well for the y. So the y coordinate will be y 1 times minus 2 is minus 2. Minus 2 add 1, right? So will become minus 1. So that's the last final result. Now let's calculate this point. This point will be 0 times with minus 2, which is 0. And then subtract, shift to the left 2 units, so subtract 2. So this becomes minus 2. And the 0 for y times with minus 2 here, the factor of expansion of a, 0 times minus 2, which is 0. 0 adding to 1, so it becomes 1. So now, the next point, x is 1, we're going to time with minus 2, so become minus 2. Minus 2, add minus 2, right, because we shift 2 units to the left, so we subtract 2. So 1 times minus 2 is minus 2. Minus 2 is minus 4. And 1 here for y times with minus 2 will be minus 2. Minus 2 add 1 will be minus 1. So the next one, the x here is 3, right? Time with minus 2 will be minus 6. It means including the reflection, right? Because the sign. So 3 minus 2 is minus 6. Minus 6 minus 2 will be minus 8. And 1 here will multiply with minus 2. So become minus 2. Minus 2 add 1. So minus 1. So let's plot this point here. Remember, on the right side is our new y, right? Transformation. So the first point, minus 2, 0, becomes 2 and 1. So let's plot that. Will be 2 and 1. So that's the point. The next point is 0 and minus 1. So 0 and minus 1 is just 1. The next point is minus 2 and 1. So minus 2 and 1, so this point right here. And minus 4 and minus 1. So minus 4 and minus 1 is down here. Minus 8 and minus 1. So this is 4. So the a have to be all the way this way. And minus 1. So something like that. So now let's sketch it. Okay, do I miss any point? Okay, so we realize that this is the reflection over the y-axis, right? So it looks like this way, right? As you keep going. And one. I miss anything? Okay. We gotta be careful about the way we will shape it, right? Let me see. Okay, so let's follow the order. So we're talking about minus 2 and 0. So we start from this point and thus become 2 and 1. So I have to mark the order, okay? So this is the first point we're talking about. So this is the first point we're talking about. We become 2 and 1. The next point we're talking about minus 1, 1, which is this point, is the second order 2. So become 0 and minus 1. So this is 2, right? Second order, 0 and minus 1. Now the third point is 0 and 0. 0 and 0. So this is the third point. 0 and 0 become minus 2 and minus 2 and 1. So this is the third point. And then the next point here is 1 and 1, which is the fourth point. So 1 and 1. 1 and 1 become minus 4 and minus 1. So minus 4 and minus 1. So that's number 4. And then the next one, the last one is number 5. Number 5 is minus 8. So this is number 5. Okay, so let's follow the order. So we start from 1. We start from 1. We connect to 2. So it looks like C1 and 2. So we have to connect this way. So let's analyze the image after we complete it. As you can see that if we talk about the transformation, we see that based on this circle, you can see that we have a vertical stretch. And that's why this short circle become a tall circle, because we have a vertical stretch. Secondly, we have a reflection. This circle is parabola is opening upward. Because the reflection now is opening downward. So that's correct. The next reflection is reflection over the y-axis and horizontal stretch by a factor of 2. So you can see that by the shape, if we just look at the circle here, this is a narrow circle. This is enlarged circles by a factor of 2. So yes, the horizontal expands, right? And also, we're talking about the reflection over the y-axis. So you can see that this linear on the left now become reflect to the y-axis, so become this line. Now this linear on the right, and we have a reflection over the x-axis, so it moved down. Instead of up here, it moved down here. And because it's reflection over the y-axis this way, so this linear on the right now become on the left. And what else do we see? So it very much, we know that based on these notation, and based on the order of transformation, we follow the rules. We create this image correctly. And therefore, because the math is detailed and a lot of information, so we have to make sure that we follow step by step, and we follow the rules of the order of transformation as well. So that we create the image accurately and in accuracy. So I hope that you enjoy my video. Thank you for watching, and stay tuned for our next MS PowerPoint presentation. Bye for now.